Geometry Lesson 3.5a, Equations of Lines. We're going to review linear equations in the Cartesian plane. The standard form of a linear equation is ax plus by equals c. This is where neither a nor b is 0. So a and b will be anything but 0. The constants a, b, and c are typically expressed as positive integers, with a being greater than 0. As a review, to locate a line's intercepts, where its points intersect the axis, we set x to 0 when solving for the y-intercept, and we set y equals 0 when solving for the x-intercept. Be sure to have that in your notes because it can get confusing as you're going along. Let's look at example 1. Example 1 is on page 137 of your book. Use the x and y intercepts to graph 2x minus 3y equals negative 6. In your book, they have some steps to solve this type of equation. I recommend you use the steps until you're comfortable enough to do the problems on your own. I also recommend that you write the equation ax plus by equals c to keep your variables and numerical values straight. So the first thing we're going to do is locate the y-intercept. So we take this equation and we set x to 0. So instead of having 2x minus 3y, we'll have 2 times 0 minus 3y will equal negative 6. Using algebra, 2 times 0 is 0, so we end up with negative 3y equals negative 6. And we solve, and our y-intercept will be y equals 2, and our y-intercept will be 0, 2. 0, if you remember, is the coordinate x1, and 2 is the coordinate y1. And I encourage you to write those down also when you're doing the problems. So we've found our y-intercept, and now we're going to locate the x-intercept, and we'll set the y to 0. So 2x minus 3 times 0 equals negative 6. 2x will equal negative 6. And x will equal negative 3. The x-intercept will then be negative 3, 0. So the coordinate x1 will be negative 3, and the coordinate 0 will be y1. Now the third thing they tell us to do is plot the point, actually that should say points, plot the points and graph the line. So we have our y-intercept and we have our x-intercept. And let's take a look. 0, 2 on the y-intercept. Here's 0 at the origin, and 2 on the y-axis is right here. I'm going to make an attempt to actually add a point. We'll see what happens. And now we'll go to our x-intercept, which will be negative 3, 0. So 1, 2, 3, negative on the x-axis, and 0 on the y-axis, and that will be this point. So we have our 2 points, and you draw the line through the 2 points. Whenever you're making a graph, if it came from a linear equation, you want to graph that equation on the graph also. If we solve the equation from example 1, we have 2x minus 3y equals negative 6. We subtract 2x from both sides, and we have negative 3y equals negative 2x minus 6. We divide both sides by negative 3. Negative 2 divided by negative 3 is a positive 2/3 x. Negative 6 divided by negative 3 is a positive 2. What we're doing is converting the equation into the slope-intercept form, which is y equals mx plus b. This should look familiar from algebra. In this formula, m is the slope of a line, and b is the y-intercept, 0, b. So in the formula, 2 would be your y for your y-intercept. This would be b. Lines can be graphed quickly with the slope-intercept form. Example 2 on page 138. Write 3x plus 4y equals negative 4 in slope-intercept form and graph the equation using its slope and its y-intercept. So let's begin by solving for y. 3x subtracted from both sides of the equation leaves us with 4y equals negative 3x minus 4, and we divide both sides by 4. We have negative 3/4 x minus 1. Continuing on, let's look at the graph with the information that we solved for. So our equation was y equals negative 3/4 x minus 1. Plot the y-intercept, which is 0, negative 1. So if I go to my graph and I start at the origin, we're going 0 on the x-axis and we're going to negative 1 on the y-axis, and there's our first point right here. We use the slope, which is m, which is the rise divided by the run, or it's the negative 3/4 in the formula, to plot a second point. From the y-intercept, which was right here, we will go negative 3 in the rise, 1, 2, 3, and positive 4 in the run, 1, 2, 3, 4. And that's our first point. And we can actually use 2 points to draw a line. Now it's always a good thing to do another set of points just to make sure that you've graphed this properly. So you take the rise and the run and you reverse them, and this time we'll go rise as a positive 3, 1, 2, 3, and our run would be a negative 4, 1, 2, 3, 4, and we find that that set of points is also on our line. So we've graphed this correctly. Lesson 3 5a, your homework is numbers 1 through 10. Numbers 1 through 6, use example 1 to complete the problems. Numbers 7 through 10, use example 2. If the problem is already in slope-intercept form, begin at step number 2. If you have difficulty with numbers 7 through 10, contact me right away. I'll run you through the problems, and we can give you a couple more problems to practice with to make sure you have the concept. Let's do a couple of homework problems from this lesson. You're asked to find the intercepts and then graph. So let's begin by finding the y-intercept, and for the y-intercept we set 0 to x, and we have 0 plus y equals 2, which is y equals 2, and our y-intercept will be 0 and 2. So x1 will be 0 and y1 will be 2. And let's go ahead and graph that right now. And this is the y-intercept. So x will be 0, so begin at the origin and go up 2 on the y-axis. Now let's do x. For the x-intercept, we set y to 0. X plus 0 equals 2, which is x equals 2. And so our points will be x1 equals 2 and y1 equals 0. So x will be 0 on the x-axis. X will be 2 on the x-axis and will not have any rise because y is 0. We plot that point and we draw a line through it. Let's take a look at number 7. Now number 7 will be like example 2, and we are asked to use the y-intercept and slope to graph each linear equation. This equation that we were given is already in slope-intercept form. So right away we can figure out what our y-intercept is, and this is our b in the formula, which is -5, and our x will be 0 because we are setting the x to 0 for the y-intercept. Our slope will be whatever variable is in front of the x, and even though there's no variable listed there, it will be 1. So our slope is 1 over 1. So let's go ahead and plot the y-intercept, and we begin at the origin, 0, and we have a -5, so we'll go down 5 spaces, and here's our first point. And from this point, we will rise up 1 and run 1. So we'll go up 1 and over to the right 1. And you only have 1 point here, so we will continue doing 1 over 1 until we have a line form. So up 1 over 1, up 1 over 1. Once you've plotted 2 or 3 points, you could draw a line through, but I went ahead and did several points, and then I did the line. And now you can see that these are plotted correctly, and you have done your slope correctly because you do have a line. Record the formulas for standard form of a linear equation and for slope-intercept form in your notes. We'll talk to you in the next video.